Good morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic like LT panel and MCB. These are the contents which I am going to discuss today, like what is an LT panel, what is the connection diagram which is used in the LT panels, and what are the different types of panels which we are using, and different types of MCBs. What is an LT panel? An LT panel is an electrical distribution board that receives power from transformer or generator and distribute it to the various electronic devices and distribution boards. That means it takes the power from a generating station by using a transformer in the middle so that the voltage can be transformed, and after that it is given to the various electronic devices based on the voltage level of the electronic device and to the distribution boards. So the LT panels are used in industries for internal as well as for the external use also. LT panels are used in industries for internal as well as for the external use also. What are the panels used for? Here you can see LT panels are used to distribute power to various electronic devices, as I previously said, and LT panels are used in multi-storied residential as well as commercial buildings. So there are different types of buildings like residential buildings as well as commercial buildings. They may be of a single floor or multi-storied. So for both the types of buildings we will be using these LT panels. LT panels are also used to control the electrical power supply in devices like air motors and air conditioners and drivers. Means these panels, LT is nothing but low tension. LT is nothing but the low tension, mostly for low amount of or low value of voltage. So at low voltage levels we will be using this LT panels. For high voltage levels we will be using the HT panels. So here in this topic we are discussing about the LT panels, which is being mostly connected to the residential as well as small or multi-storied commercial buildings. What are the features of LT panels? LT panels are used to withstand different climate conditions also. Means at different climate conditions, whether it is a rainy season or a summer season or like moist atmosphere also, for all different types of atmospheres we use this LT panels. So they should be rigid or like that for all the climatic conditions. LT panels are designed for safety of operation and for maintenance also. Means if we want to do any kind of maintenance work or a repair work is going on in a building or a commercial building, we need to switch off the power circuit and then we need to do the repairing work. So before the maintenance we need to switch off. For switching off we will be using this panels. And for safety purpose also, if at all any accident occurs, during that case also we will switch off these LT panels. Now LT panels are cost effective and easy to maintain. These LT panels are cost effective and easy to maintain. So these three are the features of LT panels. Next one is how the LT panels compare with the HT panels. As I said, LT means low tension and HT means high tension. So HT panels are used for high tension cables, that is higher values of voltages, and HT panels are essential for large scale high power applications. HT for high power applications and LT for low power applications. Here you can see the picture of an LT panel, where here you can see the connection which is given to the transformer, and this is the connection given to the DG, that is digital generator 1, and this is another diesel generator 1 and diesel generator 2, and for transformer and for other electronic equipment different panels are being connected. All these panels are placed in a single board, that is LT panel board. This LT panel board, here you can see it is used for distribution of 415 volts power supply. This is mainly used for 415 volts power supply, that is for 3-phase supply. For 3-phase supply. The low tension system is received from two sources. One source is received from transformer outgoing with a voltage of 433 volts, and the other is received from the DG synchronization panel. The LT panel power system is distributed to many feeders again. That means from this particular panel, there are many feeders which are being connected to it. So, the LT panel image is being mentioned here. As I said, in this image, the connection with transformer and different DG systems are being shown here. This is another LT panel connection diagram, where here you can see this is a transformer with delta to star connection, transformer which is being connected to bus bar. This transformer is being connected to this bus bar, and here DG1 as well as DG2 are being provided with star connection again. These star connections are also being connected to the same bus bar using different switching devices in the middle. So, by using different switching devices for protection purpose, these DG systems as well as the transformer is being connected to the bus bar, and from bus bar again we are connecting to the different floors. Means for multi-storied building, we can connect the same bus bar to all the floors or different bus bars to different floors. As it is a 3-phase connection, we will be having 3 lines, that is R, Y and B. So, for few floors, we can connect the R phase. For few floors, we can connect the Y phase, and for few floors, we can connect the B phase. So, here you can see different types of connections for different floors from the same bus bar, which is being fed from the transformer and which is being connected to the DG system by using different protection devices or different switches in the middle. Important components of the LT panel. The first one is measuring meters. We need different types of measuring meters in the LT panels. Like measuring meters are used for measuring the system parameters like voltage, current, and for multifunctional meters also used for measuring the frequency or for measuring the speed and voltage or power consumption. First one is digital multifunction meter. The digital multifunction meter are used for measuring the current, voltage, energy as well as the power factor. That means it can measure the current I or voltage or energy or the power factor. The second one is energy meter. The energy meter, it has different types of energy meters are being used for measuring the power, like for 3-phase dual source or 3-phase single source also. So for both the types of sources, we can use this energy meter to measure the power. The third one is analog amp or volt meter. That means it is an analog meter. We'll be having digital meters as well as analog meters. This first one is the digital meter. The third one is the analog meter, which measures the current as well as voltage and are used on electromagnetic function. So based on the electromagnetic function, it can measure the current as well as voltage. The second is indicators and selector switches. Means there are different types of indicators or different types of switches are being provided in the LT panel to indicate if there is any kind of a problem in an R phase. So where the R phase is being connected. So to know the place where the fault has occurred, to know that different indicators are being provided in the LT panel board. So the first one is indicators, which are used to know the status of the panel operation, and different type of indicators are used with different colors also. So different types of indicators are used with different colors at different places to know the place of fault. So the first one is R phase, Y phase, B phase, ACB on, that is the circuit breaker, whether it is in the on condition or off condition or in a tripping, or is it in tripping condition, and MCCB, mounted case circuit breaker, is in on condition or off condition or is in the tripping condition. So to indicate all these different things, different indicators are being used in the LT panel. The third one is protection relays. A protection relay is an automatic switching device which senses the abnormality in electrical circuit and provides a tripping signal to a circuit breaker for tripping the resultant, for tripping the remaining circuit, so that we can protect the remaining circuit. The protection relay is used for LT panel safety, which is installed in LT panel as different types like differential relay, reverse power relay, over voltage relay, under voltage relay, and earth fault relay. Means there are different types of relays, and based on the application, based on the location, we will be using these different types of relays or protection relays. First one is differential relay. A differential relay is a commonly used in generators and transformer panel, which is used for protection of any abnormality in the input or the output power supply of DG system or in the LT panel. The main function of differential relay is to compare the input and output current difference. If any side current value is low or high or as per the set value, then the differential relay will be active and the circuit breaker will trip. So based on the current value which is measured on the input side as well as the output side, based on the difference in the current value, the circuit breaker is being operated, that is, it will trip. Next one is over voltage relay, OVR. You can call it as OVR, that is over voltage relay. It is also an automatic switching device which senses any abnormality in voltage. Previously, it was sensing the abnormality in current. Now this is measuring the abnormality in voltage variation as per present value. Then it will provide a tripping signal to the circuit breaker so that the remaining system will be in a safe condition. Now, the over voltage relay for protection against the over voltage, because due to the over voltage, the insulation may be damaged, and fire accidents may occur. The over voltage relay is used in multiply of 5% voltage of 415 volts. That means here we are giving 3-phase 415 volts by using a transformer. So, multiples of 5% voltage is being measured or detected. So, it is used in LT panel or isolation panel of a transformer outgoing. That means the output of a transformer, in that place we will be measuring the voltage. The third one is under voltage relay, that is also called as UVR. It is an automatic switching device when senses an abnormality in voltage variation as per present value. Then it will provide the tripping signal to the circuit breaker so that the system will be in safe condition. Under voltage, because due to under voltage, the equipment will take more current, resulting due to the over current insulation may get failure. That means the over voltage as well as the under voltage both are being detected here. Next one is earth fault relay. Earth fault relay is an automatic switching device which is used for sensing the current leakage. For current leakage as per the present value of current leakage. It is used in LT panel and HT panel and in other electrical panels also. The leakage value of current can be set up to 20 to 50% of the equipment current rating. So, this is depending upon the equipment current rating basically. So, based on the current rating, 20 to 50% of current, you will call it as leakage value of the current. Next one is reverse power relay, that is RPR. RPR is again an automatic sensing switching device which is used for protection of reverse power in DG incomer panel. That means to the input side of the panel. When the power supply is switched off, DG backup supply will switch on. During this period, the EB power supply completely switch off the other leakage current and it may be dangerous to the remaining system. So, in order to reverse the power, relay is being used with quicker time duration. So, this is the reverse power relay. Next one is circuit breaker. Circuit breaker is used in LT panels for switching the power supply for incoming as well as for the outgoing feeders both. Generally, there are two types of breakers which are being used in LT panels. These are air circuit breaker and molded case circuit breaker, ACB as well as MCB. This breaker is used in LT panel. It works as a switching device manually or automatically. In both the cases, it is used for controlling and for protecting the electrical system from overhead as well as short circuit conditions, overload or short circuit conditions. MCB. MCB is used in LT panels for switching and controlling from the overhead as well as short circuit, and generally it is used to 800 amperes in LT panels. So both the circuit breakers ACB as well as MCCBs are being used in these LT panels. Low tension panels are mostly made up of several components, like they include different components like main circuit breaker, the bus bars, different types of fuses at different locations, the control relays based on the load which is being connected to these bus bars, different metering systems which can measure the current, voltage, power as well as the power factor, and different types of indicators to indicate whether the current is flowing or any fault is occurring at any location. Next one is capacitors in order to do the power factor correction. In order to improve the power factor, different types of capacitor banks may be connected at different loads, near the different loads. Next one is automatic power factor controller, that is APFC. This controller automatically switches the capacitor banks to maintain the power factor. So these are the different important components which are being connected to these LT panels. MCB. To understand the components working principle of miniature circuit breaker and its advantages over the traditional fuse. Here you can see the cross-sectional view of an MCB, and here you can see the knob as well as the solenoid. This we have already discussed in the previous class regarding the different types of circuit breakers in that topic. These are the main parts of the MCB, that is the thermal unit as well as the magnetic unit. On and off condition, here this is the on condition, this is in the off condition, where here you can see the, based on this we can decide whether it is in the on condition or off condition based on the knob position. This is the comparison between the MCB and the fuse, where MCB trips off in the case of excessive load and fuse melts or in the excessive case. That means the same MCB can be used when the load correction is being done, but in case of fuse we need to replace the fuse because the fuse melts at the excessive load conditions. So the MCB is to be just put on after the correcting. That means after correcting the load we just need to switch on the MCB. Fuse needs to be replaced. Since we do not change the MCB, there is no risk of putting on the MCB or switch even under the fault. Okay, so there is a risk of putting the switch in this case. Due to ignorance, high capacity fuse wire is being positioned. The compact, it is very compact and it is a small equipment. It is a porcelain base and a top, and it is not that attractive, and works in bimetal expansion or induced magnetism. Works on melting fusing due to the high temperature. That means it melts because at the high temperature. It is relatively costlier than the fuse, and the fuse is cheaper when compared to the MCB. So these are the differences or the comparison between MCB as well as fuse. Advantages over the fuse. There are different advantages, like it can easily identify the fault zone. It is simple to resume the supply. That means we can easily switch on again after rectifying the fault. And it is electrically safer. It is more sensitive to the current. It is reusable. The maintenance and the replacement cost is also very less. So these are the advantages over the fuse. That means MCB is more advantageous when compared to the fuse. These are the different applications like home electrical panels and in ground fault trip mechanisms when connected to the different lighting systems for different industrial applications as well as different types of heaters also. So these are the different applications. In next topic, I would like to discuss about the DG system, that is diesel generator systems. Thank you.